Looking at number 13, I'm going to start with the left side because it's not in terms of sines and cosines right now. The right side already is. So I'm going to start, not the only way to do this, but I'm just going to convert into sines and cosines. So I have, let me back up here. Okay, so I'm going to turn it into 1 over cosine theta minus cosine theta over 1. Now I'm going to write it over 1, so you remember once we start writing fractions, I want you to know what's on the top and what's on the bottom. So that's just the numerator right now, and then the denominator would be 1 over cosine theta, and then also also cosine theta over 1, but this time we have a plus sign here. Okay, well I'll tell you what, just from experience knowing these, I definitely have what we call a complex fraction, fractions within fractions. So what I want to do is I want to think of some way to not make that happen. Well, my denominator for all of these are cosine. So I'm literally going to multiply by cosine theta on the top and then cosine theta on the bottom, remembering that what that's going to do, and don't forget, you need to show all of your work as you go through this, that's going to distribute through, and that would create just a 1. And minus cosine times cosine would be cosine squared theta there. And then when I do the same thing on the bottom, I get a 1. And then I distribute to the second part, I get plus cosine squared theta. So what that does is that makes me do this right now. That makes me take this and write a smiley face because I am happy because I am looking right here and I'm trying to get there. So remember, we are only working with one side, but we can see with our identities, hopefully, that that numerator is really the same as sine squared theta, and the denominator I don't touch because the right side has that. So I'm done. I got it. Yay. All right, so now I move over to, I'm going to do number 16 here. Now, I'm not going to expand out secant of 2 theta because I could most definitely do that. It's not wrong to do that. But I'm going to work with this side because I, once again, might have some direction of where to go. So I'm going to start with thinking about what secant squared is. Well, kind of like the one we just did, I can write it as 1 over cosine squared theta divided by, and then I'll have 2 minus 1 over cosine squared theta. And I'm going to write that 2 over 1 once again. So now what do I got? I've got another complex fraction, common theme here. So if I multiply top and bottom by something, I'll be able to possibly get rid of my ugly fraction. So again, the common denominator is going to be cosine squared theta this time, all over cosine squared theta. Well, here we go. When I multiply the top by that, that's going to give me 1 over cosine squared theta times cosine squared theta. Well, that's literally just a 1 on top. And then I have on the bottom, well, remember, we're going to have to distribute through. So that would be 2 cosine squared theta minus, and then when I distribute this through, again, we're going to get a 1. So now, if you're not learning your identities, you might be a little confused on where to go, what to replace. But if you are learning your identities, that means that you know what that is right there. That item I highlighted is cosine 2 theta. That's one of them we learned. So, running out of room here, but that would equal 1 over cosine of 2 theta. Remember our flashcards, we have 3 of them, and that's one of them. Well, wait, that's confusing. Oh, if you didn't make this connection before, you probably are now. 1 over cosine 2 theta would be exactly the same as secant of 2 theta, and we are there. We made it. All right, another double angle identity. I'll try one here on this video. Is number 18. All right, so number 18 here. Let me switch colors. I'm there now. Again, there's 3 ways to convert this one into that. 3 identities to choose from. I'm going to start with the right side, and I'm going to do what most kids like to do, and that's to convert into sines and cosines. So here I go. Cosine over sine minus sine theta over cosine theta divided by cosine theta over sine theta plus, man, this is really sloppy handwriting and I apologize, All right, so here we are, common theme. If you've been watching the earlier parts of this video, is that I want to multiply by a common denominator. Well, my common denominator this time is actually sine theta cosine theta. So I'm going to multiply the top by sine theta cosine theta, and then the bottom by the exact same thing. Don't forget, this is mathematically legal because we're really multiplying by 1 here. So when I take and I distribute that to both parts, on the top and the bottom, something nice kind of happens here. Not going to show all my work, but I'll talk you through it. When I bring this through, the signs will cancel, but then we'll have cosine times cosine, which is cosine squared theta, minus cosines will cancel on this one, leaving sine squared theta divided by, and then when I distribute through on the bottom here, very similar, but a tad bit different because we will get cosine squared theta plus sine squared theta. Do we like to see cosine squared theta plus sine squared theta? We do, because that is really just the number 1. So as you can see there, we have cosine squared theta minus sine squared theta over 1, and I'm kind of running out of room, so I'm just gonna write it and then talk about it. I won't write the last step. Well, maybe I'll try because I don't want you to skip it, but basically that is, whoops, cosine of 2 theta. There, I got it in there. That's the same as that one right there. Okay, so basically these 3 problems I've shown you dealt with taking a complex fraction and multiplying by a common denominator to make life easier there. Okay? Hope that helps.